Introducing Roberto Meli. He'll be presenting effort estimation, an integrated framework. He's the CEO of DPO for over 25 years. In 2010, he created simple function point method, and I'm sure he'll be talking a lot more about that. He's written over 100 papers for conferences, books, and workshops, and he's worked as a trainer in project management and software cost estimation. So welcome, Roberto. I'll stop my share and Roberto can share his PowerPoint for us.
Okay, thank you very much, Paula. And good morning, good evening, good afternoon to everybody, depending on your time schedule. I will try to share my screen and start the presentation. Okay, can you see the screen?
Yep, everything's perfect.
Good. Okay, just... Okay, I had some problems with the screen. Okay. Well, I would like to share my experiences and my ideas with you in this webinar, and I'm very happy to do that. I know many of you. I know that many of you are really deep experts of the matter, so I will say some concepts which are probably very well known by some of you, but could be useful to other people who are probably starting this kind of journey through the data and through the estimation models. So let's start from magic, because everybody is looking for magic in ICT project estimation. And you would like to have a very simple solution for every problem of estimation, but unfortunately, it's not really like that. We have to struggle a little bit in doing things, but we can manage it. So first of all, some very few words about my company. My company is DPO, is Italian-based company. We were born in 1967, so a very long time ago. I started to manage this company in 1990, and it is a company which operates in the field of software management, project management, and requirement management and life cycle management, above all. And we also have a unit for HR services. Okay. The starting point, in my opinion, is that the software effort estimation is a really challenging task. The first question for you is this: have you any problem in using a black box tool? Because if no, then the webinar finishes here for you. And unless, I mean, if you like to use a black box and giving data and obtaining results without knowing what is happening inside, then probably you will find not useful all the ideas and concepts that we will explore later, because we will open the box. We will try to open the box and to look what it is inside. It's perfectly right to do that. So I'm not saying that the only way is to opening the boxes, but you can even use commercial tools if you like them and if they give you good results. If you have customizable tools, also you are in the right place and right time, because we will look at some models that could be implemented into many commercial tools. I will present you a framework which is named VAMOS R3, because it's a valorization model for software, and it's estimation model that we put together to represent all the experiences that we have made on the market in the past 20 or 30 years. So let's start from the idea that the ICT project is not just software, but also hardware components, commercial softwares, commercial off the shelf, as we usually call them. And usually hardware components have listings, have price lists and so benchmarks and so on. So also commercial off the shelf have usually monopolistic or sometimes not monopolistic listings and price lists for services, for things to be done, but it's always difficult to understand what is the real cost of something to be done because there are not many checking models to challenge the supplier's offers, for example. But we will concentrate on the third aspect, intangible services as ad hoc services. So this is the most challenging area because we have models, we have experiences, we have many long-term models like Kokomo, for example, but we still need knowledge there, knowledge development there, because the way in which the software is produced is really rapidly changing. It has changed over the 40 past years, but it is really rapidly changing in these days from one month to another. For example, if you think at the impact of artificial intelligence in the production process. So we need models that follow, that are linked to the different way in which we produce and the costs that are generated by this. Let's start from what's happened in the market in the past. The most diffused model in Italy, but also I know in other countries like Brazil, like other countries where the public administration is particularly strong, there was a fixed price for function point model. You have big contracts based only on one parameter or few parameters that define the price of software development or enhancement, functional enhancement project. Very often, the non-functional requirements and the process requirements and constraints, as we know from the ISO standards, are confined, relegated to service level agreement. And this is a problem because they don't contribute to the cost model, but they contribute to the checking of norms of rules that have been done in the service level agreement. And so this means that every project has the same impact with respect to some non-functional requirements. And this is not true. For example, the reliability. We may have in the same contract project that have very different need for reliability, but if we have only a service level agreement and we have to reach a specific level for every project, then we spend much more money than we should need on some projects and less on other projects. So we need a model in which all the requirements that are conforming a specific project within a broad contract, for example, or within a portfolio could be evaluated for the impact that it could be could have to a project. So, sorry, going back instead of going further. Okay. The advantages of this method is that it is very easy to use. You have only one parameter, function point, you have only one productivity, and you use it and you have a result. So it is highly referenced by many contracts in the public and in the private market. But the disadvantages are bigger because the service level agreement, they tend to exaggerate and standardize the demands for non-functional process that should be instead dependent on intervention. And so this means that it does not faithfully represent reality. So we need something more. And we also need models that are hybrid because very often we have a model we have a process in which we have some configuration of standard software to be done and some programming of new software that is not configurable, which is very new. And so we need hybrid models that could be make together all these aspects in the processing of requirements, from the business requirements to the end user functions to be used. Let's introduce the work rhythm structure. This is a tool which is very known by the project management community. It's a very precious tool to manage projects, and it's also regulated by an ISO standard, as you see. And work breakdown structure is a breakdown of the entire scope of work. So in the breakdown structure in any project, we should have all the work that should be done at different level of representation, different level of aggregation. When we go to the work packages, which is the leaves of the tree, this is an upside down tree. The root is on the top hill, and then we have the leaves on the bottom. And the work packages are really the things that should be done in the project. So the activities at a good level of representation. So if we want to know how much work we have we'll have in a project, we should have a number for each leave work package in order to sum up these leaves and to have a total figure for the project. So if this is true for any project, it is true also for ICT projects. So every part of the project, every activity that should be done and that takes effort to be done should be there. So this is the most extensive representation of the work to be done. What happens with respect to the models, to the parametric models, for example, or to other estimation models that we have? How do they relate to this tool? Well, actually, we have to do a mapping, as we will see in the next slide. The usage of the work time structure is to plan the work, to assign responsibility, and the stuff that you see on the slide. I don't want to read all the aspects, but you will have in the slides when we will finish. But the important thing is that every effort should be there. And so we can use it as a comprehensive list of effort packages to be done by the project. The important is to use it in the right way, naturally. And the one important aspect is the granularity issue. I mean, the standard doesn't give us any hint about the granularity that should be reached by any work breakdown structure. It is up to you, but it is important that the work package is adapted to manage the project. So if you have a structure like this for a space flight project, this is completely useless work breakdown structure because it has no detail in any way. And so it is useful to report, for example, costs in different areas, but it's not useful to project work to be done. It's not useful to estimate work and to control and govern work to be done. So let's go to the box and try to open the box. This is, I think, one of the main crucial slides in the presentation. We have three types of requirements, user requirements in the ISO standards. One is functional requirements. The other type is non-functional requirements, and then we have process and constraints. So these are three different types of requirements that impact on the effort, but the way in which they impact on the effort is really intriguous. We have a direct correlation between functional requirements and effort through the functional productivity. Sometimes you will find some Italian words not translated, but I will correct that for the final version of the slides. So we can predict effort based on functional requirements and their measure, for example, function point. But we have also a non-functional requirement that contribute to the effort in different ways. One way is direct contribution, because we may have to set up an environment. For example, we may have to do some activities that are not proportional to function point. That's to say that if you have 100 function point on 1,000 function point, you always do the same kind of non-functional activity. So it's independent on the function points, and this is the arrow that you may see here. Okay, this arrow means that it gives a contribution in a direct way. And we will see what kind of contribution with respect to the quantity later on in a later slide. We have also an indirect contribution, because some non-functional requirements, like, for example, the type of language that you will use, programming language, will influence the productivity in which you deliver the single function point. So this means that you have not a certain amount which is independent of the functional requirement, but you have an amount which is variable depending on the quantity of functionality that you have to deliver. Let's make an example. If you have a requirement for usability of transactions, and you have to work each transaction for a usability issue, for a usability goal, then you may have effort which is proportional to the number of function points of the transaction that you have in the product. And sometimes it's not like that, because you may release for example, styles sheet in which you make all the transaction coming in, and then you have worked only once on a template, and then everything is applied automatically. So you have an issue of a non-functional requirement which is related to the usability of the system, which is not proportional to the function point. So the same type of requirement once could impact directly the effort, once could impact indirectly the effort through the number of function points that you have in the product, for example. Then some non-functional requirements, not all, some very specific requirements could transform into functional requirements. Could, more than transform, we may say, imply. And so, for example, if you have to realize a wizard to help the user to use the system, this is a functionality that you will count in function point, because it's a way to arriving to the same goal, the same functional goal, instead of directly using a form, responding to questions and having an incremental way of reaching the goal or achieving the goal. So this is a functionality, but it is also contributing to the usability of the system. So it's both them. So the contribution could be in a different way, and this is also true for the process requirements, which are directly contributing or indirectly, which means proportional to the functional user requirement. These are more like, if you know the model COCOMO, more like the adjustment factor that you have in that model and that adjusts for languages, for experience of people, for capability of people, and so on. So this is the most comprehensive model that I can imagine if you add the work breakdown structure aspect as well. There are some activities who are not implementing in this schema, yes, and so you have to keep in account it. You have to take in account those activities in a direct way, with a direct estimation, as we would see in few minutes. So a mapping is needed. When you have a work without structure describing your project, you have to understand which work packages are included in which model. For example, let me okay, go again to which work packages will be covered by the functional user requirement model of productivity of production, which one by the COTS model, which ones by the non-functional requirement model, in which you may measure some aspects of the non-functional requirements, and which one should be covered by direct estimation. This is very important because all of these make the total. So the most complete, most extended model is the following that you see. It seems quite complex, but actually it is made of simple relations. The important thing is that we have to sum all those aspects to have the total project cost. So we have the effort for the functionalities that you have to build here. You have the effort for the configuration of items in COTS. You have the effort for sizable non-functional requirements, for example, with the SNAP model or other models. You have a non-sizable non-functional requirement that should be estimated directly by experience, for example, and you have also project requirements and constraints that should be converted to effort to give all the components that you need. Yeah, if you have all of them, then you have a good estimation of your project. This is the pyramid of the process. You start from sizing, you convert to effort, you have different efforts and you combine them, and you add the project and constraint, and you have the total. This is another way of seeing them, but this is very similar to the previous slides and approach. I just want to say that for measuring the configuration aspects, we may adopt methodologies like adaptation point or other methodologies that are based on configuration items. I don't want to open this window because it's too big to deal with, but you may find in the reference some ideas and some links. So how are estimates made up? Direct estimate means that you look at the things and you have an idea of the total that you want. And this is strongly based on intuition, on something that is very often takes place below the level of awareness. And so for these reasons, it could be affected by many problems. For example, the psychological pressure, the need to contract resources, the experience of the estimation method, the time available to estimate, and so on. And cognitive traps as well, biases that could affect your way of thinking, which without even knowing that. So these are the problems in the direct estimation, but we need that. We need that because we cannot avoid in a situation where you have no models. to deal with the new aspects, to deal with the requirements, product requirements or process requirements that you cannot standardize, and you cannot have data about that. So the indirect estimation model, parametric models, is a simulation model. Is something which you put inputs and you have outputs based on data set, historical data set, and on algorithms and the heuristics that you may have set up into the model. So this is the black box I was telling you before. And if you know what's happening here, then the black box is a transparent box. Otherwise, it's a black box, and you have only to trust the people that gave the truth to you, and on the results that you eventually have already had on that model. The estimates are made during time along the life of the project, and so you can have approximate models at the beginning and detailed models later on. Let's go to the functional user requirement models. They are based on the classical functional size measurement models. There are many of them. The most diffused are these, but there are others that are also ISO standards. And all of them are based on a model like this. You measure the input, you measure the outputs in terms of data that are going in and out to and from the application. You have data movement that are going inside and outside, and you have data manipulation, which is algorithms. They are not very really measured at the moment in a sizing strong and consolidate model. And you have data stores, which are the historical part of the information system. You have different ways of measuring them, but you are more or less measuring those things in the functional size measurement model. For custom components, you can develop a model, a production cost model, which is based on function point. As we said, there are some challenges that we have to face in this period, and these are impacting the size. For example, the level of reuse that you have on system. If you have half of the system already done, and you have to integrate it, you have a size which is already done, and you have a problem of integration of that size, product size, into the new product or the enhancement product that you are changing. And so you have to consider this, and you may use size to evaluate this contribution of the reuse in a better way. And we have also replication level of logical objects on different platforms and channels. And this is depending on which guidelines you use. For example, we know that sometimes practitioners evaluated separately transactions that are exactly the same, logically speaking, but they are physically coming on different channels, for example. Sometimes there are different opinions on that, and if you deliver the same functionality, exactly the same functionality in terms of logical processing on different channels, then you may have an effort to test them, even if you have not an effort to define the requirements of them, because they are exactly the same. And probably also you don't develop programs for that, because you have automatic translation of one language into another for some environments. So you have to consider what kind of effort you have for replicating a functionality in physical different channels. And then you have the algorithm component of elementary process, which is not satisfactorily measured at the moment. We have not a good model to measure the extension of algorithms, and not only the complexity, because the extension size is extension and complexity is orthogonal to extension, is something which is related more on the relation between the parts and not on the number of parts. So complexity and extension are two different concepts, and we should need both them to measure actually algorithmic component of functionality. But they are impacting the productivity, they are impacting the effort. So we need to have that, but in the future probably we'll have. So the question is, does the effort and the cost depend on the function points, on the functional size measurement? If you look at the data, you see that the data, ISBSG data, for example, this a plot of the release that you see here, they distribute as a cloud, not as on a line. So this means that they are dispersed with respect to an average that could be represented by this. By the way, this is a logarithmic plot of the data in the data set, because the data set is skewed and it is very populated in the low part of small projects with respect to medium and large projects. So very often in statistical analysis, we use the logarithm functions to normalize in some ways the techniques that we use to analyze the data. But anyway, I just wanted to show the fact that they are dispersed with respect to an average or a median or whatever. So we know that from 60 to 80% of, statistically speaking, of the variation of effort is linked to variation of function points. This depends on the model that you use, on the filters that you use, on the data sets, and so it's really depending on the study that you made, but not less than this and not more than this. So we have to understand that we have to capture all the other aspects, because even if a determination index of 0.7, it is a very good index for judging an estimation model, for example, it is not sufficient to managerial and operational aspects, because you have this problem. When you estimate using the average or using the median or whatever, you are here on this curve, on this representation. And if your project is here, this is the amount of underestimation that you do. And keep in mind that this is a logarithmic scale, so it's much more than you can see. So even if the model is good for large numbers, for a single project, you need to go from here, from the place where you use the model for the average, and the place where the project will really be in the from probably in the future. So you need to have other aspects to be considered for each project to close to put the estimation closer to the actual values that you will have. And the same could be seen on the opposite. In this case, it's very highly overestimated, the project. Sometimes in the realities, you don't see all this part in actual organization, because there is the law of the expanding gas. So if you give an estimation which is higher than you would need, the project will keep all the space that you give like a gas, and it will not show and not release any resource to the usage for other projects. So you will not see this part, and you will see only when it is not, the budget is not enough for the project. So this is a problem for the organization, because a lot of money is wasted in this part, and you even don't know that you are wasting money. Okay? So, if you look at models, we have one study, very good study made by IFPAG, and this is the result based on the analysis made with some filters that you see on the database, and you see the formula is 12 here, which means that in order to have hours, you have for the project, you have to multiply 12 or less 12 by the number of unadjusted function point, and you have an estimation of hours. And this is the determination index, very good. The number of projects is not very high, but anyway, the results are statistically consistent and good. And this is another example with another type of filter, and you have a similar value and a similar in the determination index, and you have a different database, different filters. I mean, for example, these are only quite recent projects, only 3GLs and 4GLs, and data rating of A and B. So you can change the rating, you can change the data, you can change a lot of things, and having a result that you use. Here we have used the normalized level one work effort of the ISBSG database because we want the total effort for the projects. And this means that there is also some work which is not really proportional to function point, as we have said before. And this is one of the reasons why the data are dispersed with respect to the fact that you are putting on the cost per function point also some activities which are not proportional, which have a different impact on the total figure if the project is small or if the project is high. If you have, for example, 20 person days to add to the project, and you have a project of 50 function points, then you have an impact of these 20 days much more important than if you have a 1,000 function point project. But you have always 20 person day for that part of non-functional requirement. Okay, so this is why it's not a good idea to put the non-proportional costs for a project to non-proportional to function point cost of a project on the price, on the productivity for function point, because then you have a lot of noise more than you may have. This is an example of customization. You may have a similar approach. I just have to look at the clock before going on. And you may have an approach instead of basing on BFCs of the functional measurement method, you may have a different approach based on, for example, SAP schema or whatever, and then you may extrapolate the function points, in this case, the simple function points, and to use the same model, or you can do in another way. You may use a methodology like adaptation point. It's just like configuration point by Gardner Group. It's a way of measuring not the functionality that you deliver, but the configuration parameter that you have to change to deliver functionality. Why for COTS customization, personalization, how can you say, it's not important to measure the final number of function points that you deliver with the sub-project, for example, with a COTS project, because the effort is not proportional to the functionality that you deliver. They are already done, they are there, and will be delivered very easily. If you do not any parameterization, any configuration, you deliver thousands of functionality without doing much in terms of effort. You have to spend a lot, of course, but you don't do much work. Not as much you should have done to deliver the same functionalities by scratch, of course, on demand, like ad hoc software. So it's not useful to ask ourselves how many function points are delivered by a COTS project. it is more important to understand where the work is in these kind of projects. And configuration is one of the tasks that are not the only and sometimes not the most important, but it's a way to say that if you want to take in account of the effort to customize using parameters, configuration, a COTS tool, then you have to count the parameters, not the functionality that you deliver, that you change using those parameters. And so this was the idea of the configuration points by Gardner Group and the adaptation point, which is similar to that. I go quickly, and you have on the slides some more details. What activities are usually included in a functional side measure cost model? And these are usually quoted by a life cycle process. And if you look at them, even in the ISBSG dataset, they are published, they are quoted. And if you look at them, you have activities which are typically done for implementing functionalities. And you have also a lot of activities which are not included in a cost model based on function point. And you may see here many of them. And so you should have a way to keep those in account to generate the additional effort that you have to add to the model that we have seen before. And the way in which this effort is generating is one of these that you may see here. In this case, the effort is not dependent, sorry, the effort is not the non-functional requirement is not impacting at all the cost. So this is only proportional to function point, and we can use the model that we have seen before. In this case, you have a step. So you have a cost which is independent by the amount of functionalities that you deliver, and you have just to add to any point in this curve. You may have thresholds. You may have a situation where you have more than one step. For example, for volumes, you may have one cost till one volume threshold, and then after that you have another type of cost, as unitary prices, for example. And so you may have a step like model. And then you may have a model like this, which means that the non-functional requirement is impacting the productivity, the unitary productivity with which you deliver functionalities. And so it's changing the slope of the curve, the inclination of the curve. Okay. We made many studies of that, and many people have done it in the community, in the academia, and we found that with the involvement of hundreds of professionals, we identified more than 100 factors that are impacting productivity on their opinion, on the opinion of the people on the field, people working on systems actually. And not all of them are impacting the same way. I mean, they are not important the same way. Probably the Pareto law, 20% of them are impacting the 80% of the result. It's the law that is followed even here, but they are a lot. And if we don't consider them, they become noise in the model that we have seen before. So it is important to understand those factors. And especially in this period, we have quality profile, security profile, and user experience as the groups of factors which are impacting a lot the systems today, nowadays systems. Is there a way of measuring non-functional requirements in order to have only one model? In my opinion, there are no single metrics to measure such diverse elements. Not all elements are at present are satisfactorily measurable with one method. We have some examples, but we have a method delivered by IFPAG, the SNAP project, which gives 4 categories and 14 subcategories, and you may use this. My way of seeing that is that it's not a good idea to transform only one number and of snap points and to apply one productivity to those numbers, but it's better if you want to use to define a productivity for each of them because they are quite different one from each other, and there is no guarantee that the same productivity could apply for each of them. But this is the object of study today, and there are studies that are running, and we will see in the future the results of this. The most important thing is that you don't consider twice the things. So we must be sure that any non-functional requirements contribute is not already considered in the functional user requirement estimation model. Otherwise, we will consider that twice. Let's do an example. Since in the past we had no other ways of measuring non-functional requirements, and we only collected data in ISBSG for the total amount of effort for a project, we have many of these aspects that were included in the effort collection of data before. So if we estimate the effort using those data and we add effort to keep in account some of them or many of them, then we are doing that twice. So if we have a project like many called with no function points, I mean, no function point project is a project that does not impact functionality, then it's okay. You can consider all of them because they are not included in any model that you may have used because there are no functionality. But if you have functionality, you have to be very careful about doing that more than once. And in my opinion, there are many places in which this could be done. But we have no time this time to deal with that. This is an example of different aspect. We may use physical objects like JSP, for example, objects to movimentate, to change, and we have productivity for doing that. And so we have an object which is technical object, but we may have an effort estimation about that. Or we may have price list. For example, to migrate the data, we may have the number of objects to migrate, the complexity, and the unitary estimation for each object, and then depending on the number and type of objects and cycles for migration, then you may have a total effort for that. This is based not on function point, not on other aspects, but on the number of objects to be migrated. We may have a catalog services where you may have, for example, activities which have as a driver of size test case or number of HATM pages or whatever. So we may have very different sub-models to be used in a work breakdown structure approach, and we may also have a pre work breakdown structure estimate, which means the work package, which are not exceeding 10 to 15 person days, could be estimated by direct judgment, by direct estimate. And so this is made for the leaves that are not covered by any model. This is an example, and you may have many of them and represent them in the rows of a structure like this, and having the side, if you have the effort unitary or your total effort in a direct estimation, and you may have also the cost using how can you say, a rate for the people that you are using. So let's go to the conclusion so that we have some times for your question and hopefully answers or just considerations. Function points and effort are related, are correlated quite well according to some models. In the future, this will be challenged by the way of producing. For example, if you have no code or low code, we cannot use those figures that we have in the actual database because, of course, a part of the life cycle is not done anymore, or it is done with a very limited amount of resources. Let's think about the automatic coding by artificial intelligence that is coming in the future. And so we have to change the models in order to keep in account of these aspects, but it's a main driver. We still consider function points and functional measurement methods as measure, sorry, not methods, but measure as a primary driver for cost model, but we have to consider also the other requirements. So we have additional requirements to be considered with models that are in evolution in this moment. So we have to capture a lot of new experiences in this field. We are not definitely ready for that, but we can integrate part of the experience that we have in the market in order to improve the final model. And Vamos approach is a way of integrating all of them in a flexible way because you can use any kind of submodels. For example, you can use COCOMO factors within the Vamos approach because a part of the factor impacting the productivity could be think as the COCOMO general factor that are studied in that model. So we need to open the box and to understand what's happening in the box. If we don't want just to trust the tool and to accept anything the tool says without knowing what's happening inside. To close, this approach has been described into the metric views publication by IFPAG. Here is the address, and at page 23 there is a description. So I hope to have been quite clear about that. We have 7 minutes left in my clock. So if you have any question, please ask, and I'll try to answer if I can.
Okay, we have a couple of questions from Manoj Batra. They're a little bit complicated. I'll try and read it out for
I, I,
you.
I can, if you can hear
Yeah,
me,
please.
I can. Oh, thank you. Thank you for, giving such a nice presentation on, we are really struggling in automotive sector for software. So I'm part of an automotive industry where, we are estimating for the onboard software. And as you say, the process requirement, the non-functional requirements are pretty high compared to the functional requirement, which are like, the functional safety ASIL, because it's a moving vehicle, and then we have software safety application in terms of ASIL ratings. There are high quality requirement, which is like ASPICE levels 1 to 5, which needs a lot of documentation and process adaptations. And there are cybersecurity requirements based on the vulnerabilities coming with the TARA analysis, the threat analysis they count. So can we use function points for these, or these are like process requirement? How do you see these requirements?
Okay. It's a very hard question, but I think that I tried to present to you a method, not a model. I mean, not the numbers are not important, the numbers, but the way in which you approach the estimation problem. So, in my opinion, function points could be useful even in this situation. We have experiences of applying a function point in layers and in different layers of an application. The most important thing is how to put together all these things when you have finished. So the important thing is to have a work breakdown structure approach for the total project that you will deliver, you would have to deliver anyway, because if you want to manage that project, you have to deliver a work breakdown structure. This is a project management tool, not an estimation tool. But if you use that approach, then you can ask yourself the question that I asked myself before. This leaf to what model could be linked to? I mean, what part of the estimating model could be fed by this aspect? So if you have non-functional requirements for security that are completely based on architectures, on procedures, on anything that is not functionality, then you will not represent that in function point, of course. And you may use anything you want. And if you don't have anything to be used as a model in the market, then you have to estimate by direct estimation. And so you go back to the idea of having a reasonable criterion that is to subdivide the work till you have 10 to 15 person days effort to be estimated on that. So if you have a security requirement which is very complex, you have to divide it into parts until you go to a reasonable model. So my answer is function points could be used in part of project like that, but they are not certain the only answer to the estimation problem. I hope
Yeah.
to be.
No, the problem we find is in automotive we use base software or stack as an AutoSAR, which has lots of functionality. So we, as you say, no, we should not be double counting them into a stack we buy as a modular architecture, which take care of lots of things, which is like functional safety and security stacks are available. And sometimes developer has to just connect and integrate them by an integrator tool.
Okay.
So those solutions, yeah, we are looking even
Okay.
ISBSG, the automotive data is very, very less from the industry.
Yeah.
If we get that kind of data, we are using cosmic function points right now for the functionalities. But if you get ISBSG data related to automotive, that will be helping us in benchmarking, comparing with industry. So we lack that with the tool and with the data both to really validate what we do as a whole project.
Okay, I have a little addition on that question. If you think about the problem that you have said now, I have to warn about the reuse question, the reuse aspect, because when you have a layered architecture and you use the components inside the model, inside a component which is higher than the one that you have used, you have to consider that you can measure elementary process at each level. But when you have a level which is composed by many objects of the underlying level, you have to consider the use in the first object. Otherwise, you sum up all the things and you have an explosion of effort. So I agree that when you have a layered architecture, you have to consider very well the situation for adding up the total amount of effort if you don't consider reuse. Reuse in that case is very important, and you cannot
Yeah,
avoid to measure it.
sure. Sure. Thank you.
Thank
If
you
we get
for
a
your
chance, I
question.
would like to discuss more in the future. Thank you for your answer. Yeah.
Thank you.
Okay, we have one
Is there
more
any?
from Shirazad, do we have a model or a way to currently size foundation models in AI or deep learning?
To my knowledge, no, but it's also difficult to think. Well, in my knowledge, we are dealing with some of those issues. At the moment, there are a lot of measures that are taken, but no of them at the moment are emerging like sides measures. So useful to be linked to the effort to make a model like that. So if you look at the usage of a large language model, for example, then you have a machine that answers to your questions, and it's very easy to measure that in function point.
Yeah.
But that's not a measure useful to predict the cost of doing that. So for artificial intelligence, we are still in the research mode, and I don't see at the moment, in my knowledge, I don't see any model useful to be considered for the development of the models. The usage is different because it's easier, but not for the development of the models.
Mm-hmm. Okay, thank you.